Okay, so hello. Our topic for today is the Lagrange linear equation of the first order. These are the linear first order partial differential equations in the form capital P times small p plus capital Q times small q is equal to capital R, where P, Q, R are functions of x, y, z or constants. And these partial differential equations are solved by the following steps. And don't forget that small p is equal to partial derivative of z with respect to x, and yung q is just the partial derivative of z with respect to y. Okay? So these are the following steps in solving this kind of equation. So that step one is by forming the auxiliary equations. So these are the ratios of dx over p is equal to dy over q, and it is equal to the ratio of dz over r. And we're going to solve these auxiliary equations by either or both methods. So that means we can do one of these twice or two of them. Okay? So either dalawang beses kang gagamit ng grouping method or multiplier method, or pwede kang gumamit ng grouping and multiplier at the same problem. Okay? That is, we are going to find arbitrary constants. So that is our goal. Where in grouping method, we are going to pair two fractions in the auxiliary equations and find some integrable simple expressions. Iiwasan natin yung mga complicated expressions and yung mahirapan tayong mag-integrate. Sa multiplier method, it's use sets of multipliers. Okay, set or sets. That means if we are going to use multiplier method once, we are going to have one set only, or two times, or two sets, that is LMN and or L prime, M prime, N prime, okay, where L times P plus N times Q plus N times R is equal to 0, so that we can equate the auxiliary equation in a ratio where we operate those given ratio, so that the given auxiliary equations could be equated into another ratio or equivalent ratio, which is in terms of multiplier. So L times dx plus m times dy plus n times dz over L times p plus m times q plus n times r. Okay? And where yung denominator is equal to 0. Okay? So that kapag in-equate natin or i-pair natin yung new ratio na to dun sa isa pang ratio dun sa auxiliary equation, since 0 yung denominator, what will remain is the numerator equated to 0. Okay, so pamakita natin sa example yan later. So solve for arbitrary const later. So step 3 is we solve for arbitrary constants, C sub 1 and C sub 2, where yung arbitrary constants, it will be our first solution, u of xyz, and the second solution would be coming from the second arbitrary constant, which equal to v of xyz, and those two arbitrary functions or functions would be our solutions to the given partial differential equation. So the f of u and v is equal to 0, or u is equal to a function of v, would be the general solution of the given partial differential equation in the form of Lagrange. Example number 1, let's solve for x times y squared minus z squared times p plus y times z squared minus x squared q is equal to z times x squared minus y squared. So what would be our p? So that is yung mga nakamultiply sa small p. So x times y squared minus z squared. And yung q would be equal to y times z squared minus x squared. And yung r would be just the whole right side. So x squared minus y squared. So let's make our auxiliary equation. So auxiliary equation is just derivative of x over p, which is x times y squared minus z squared is equal to derivative of y over y times z squared minus x squared is equal to dz over z times x squared minus y squared. So for our next step, we choose either grouping method or multiplier method. But as you can see, we cannot find easily an expression if we pair two fractions. So convoluted by three different variables yung ating fractions, and we cannot easily separate them. So we cannot easily find an integrable expression. Okay, so we are going to use the multiplier method. Okay, so we are going to select multipliers such that the denominators could be equal to 0 when we add them. Okay, so paano natin mapipili yung mga multipliers natin? That is by looking at the denominators. So how can we make it equal to 0? So meron tayong y squared na na-multiply sa x, and meron tayong negative y squared na na-multiply sa z. So that means kailangan na pa natin mag-multiply ng iba pa. But here we can have y times a negative x squared. So it can be x squared y. So that means yung first ay kulang ng multiplier na x, and yung second ay kulang ng multiplier na y. So para maging x squared y squared and minus x squared y squared. And as we can see dun sa middle term or middle fraction, if we do that, so this first yung ating z squared ay nakamultiply na sa y squared. And that means yung z rito should be z squared also, so that it can be subtracted to y squared z squared. So ang last factor or last fraction should be multiplied by z. So we are going to use x, y, and z as multipliers. So that means this will be equal to a new ratio where we are going to multiply the multipliers dun sa both numerator and denominators of each, and we are going to add numerators and denominators. So we have x dx plus y dy plus z dz all over. So we have x squared y squared, so we distribute. Okay, so we multiplied x, so we have x squared, so xy squared minus x squared z squared plus the middle term or middle fraction, so we have y squared z squared minus x squared y squared plus, for the last denominator, we have x squared z squared minus y squared z squared. Okay, so this should be equal to 0. So we have x squared y squared minus x squared y squared, negative x squared z squared plus x squared z squared, and we have y squared z squared minus y squared z squared. So this denominator is equal to 0. Okay, so we pair one of the fractions in the auxiliary equations. Let's say we use dz over z times x squared minus y squared. So this is equal to the numerator x dx plus y dy plus z dz all over 0. So that's, as you can see, if we cross multiply it there, dun sa numerator ng left side, the whole expression would be 0. So we have 0 is equal to x dx plus y dy plus z dz. And integrating this both sides, So the integral of a constant is just equal to an arbitrary constant, c sub 1. And integral of x dx is equal to x squared over 2 plus y squared over 2 plus z squared over 2. So we can just divide the arbitrary constant by 2 so that if we multiply both sides by 2, so we have c sub 1 is just equal to x squared plus y squared plus z squared. Since 2 is just still a constant, c sub 1 is an arbitrary constant, so c sub 1 over 2 is still arbitrary. Okay, and this is equal to our u of x, y, z. So this would be our first solution. Okay, so for our second solution, again, we cannot easily use grouping methods, so we are going to find another set of multipliers where we can easily equate the denominators into 0. Okay, so if we take a look at the auxiliary equation again, we have y squared then minus y squared, negative z squared, and minus x squared, positive x squared. So we just need to remove the multipliers of the outside of the parentheses. So how do we do that? We use 1 over x, 1 over y, and 1 over z as multipliers. So that this will become, so we have dx over x since we are going to multiply also the multipliers sa numerator, plus dy over y plus dz over c. All over the denominator we have, so if we're going to divide the denominators by 1 over x for para sa first fraction, so we have y squared minus z na lang plus what's left is all the expression inside the parentheses plus the last parenthesis we have x squared minus y squared. And as we can see, we have y squared minus y squared, negative z squared plus z squared, negative x squared plus x squared. So this is equal to 0. Okay, so what remains is still we can equate it with one of the fractions. So let's use the last one, x squared y squared. It doesn't matter because the denominator that we will multiply there is 0 already. So what remains is just the numerator, dx over x plus dy over y plus dz over z. Okay, and we cross multiply it. What remains is dx over x plus dy over y plus dz over z, and this is equal to 0. So we can now integrate the whole expressions. So we have the integral of dx over x is ln of x plus same with dy over y, ln of y plus ln of z is equal to the arbitrary constant c sub 1. And why not we use ln also so that we can cancel the natural logarithm x function later. Okay, so ln of x plus ln of y plus ln of z is just the natural logarithm of their products. So we have x, y, z is equal to ln of c sub 1. That means x, y, z is equal to the arbitrary constant c sub 1. And this can be our v of x, y, z. This is our second solution. So let's have our conclusion. So therefore, f of u v, which is equal to 0, is equal to f of x squared plus y squared plus z squared and x, y, z, which is equal to 0, is the general solution of the given partial differential equation. Okay, So that's the first example. As you can see, our goal is to find the arbitrary constant. Kung saan man naka-equate yung mga yon, that would be our solutions. Let's have example number 2. Let's solve x squared p plus y squared q is equal to x minus y times z. So what would be our p is just x squared, and our q is just equal to y squared, and yung r would be, say, c times x minus y. So commutative naman yan. Okay, so let's form our auxiliary equation. So we have derivative of x over x squared is equal to derivative of y over y squared is equal to derivative of z over z times x minus plus pala to. Okay, so this is our auxiliary equation. So we can use grouping method. So from the first two fractions, we have dx over x squared is equal to dy over y squared. So dito, we can integrate easily, so we can integrate directly. So this is just equal to dx over x squared. Integral nun would be equal to negative 1 over x, and this is equal to negative of 1 over y. Don't forget, since we integrate, we need to add an arbitrary constant. Okay, so we have c sub 1. So we can just transpose negative 1 over y to the left side. So we have 1 over y minus 1 over x is equal to our arbitrary constant c sub 1. And we can simplify this or make it one whole fraction as is x minus y over x times y. So c sub 1. This is our u of x y because we don't have a variable z. Okay, so this is our first solution. So for the second solution, okay, let's pair the other two. But as you can see, the third fraction is composed of three variables, x, y, and z. And even if we equate it with the first or the second fraction, that is to find an integrable expression for the third. We can simplify it and integral some simple expression. So we're going to use multiplier method for the second solution. So for the second solution, so let's find a multiplier, right? That can be multiplied to the denominators, x squared, y squared, and z times x plus y. And how can it be equal to 0? So x squared, meron tayo nun. Then we have zx. So we need to balance them so that we can subtract, di ba? So x squared at saka x. And still, kailangan natin ng negative. So this is more, this is naka-multiply sa x ng isa pa and ito ay sa z naman. So that means pwede natin silang bawasan so that mag-equal silang x lang. So we multiplied the first by 1 over x and the third by a negative 1 over c, so that matanggal yung z. So matitira is positive x minus negative x. And ganoon din sa y. Kung i-multiply natin yung third by negative z or i-divide by negative or divide by a negative z, so matitira ay negative y. So we have y squared here. Kailangan i-divide natin to ng y. So that means we use 1 over x, 1 over y, and negative 1 over z as multipliers. So the new ratio would become dx over x plus dy over y plus dz over z all over x na lang yun plus y na lang, then minus, since we divide by negative, And don't forget, this should be also negative, because we have a negative 1 over z, minus the whole expression of x plus y. Okay, so this will cancel out. So x minus x and y minus y. So this is equal to 0. So what remains is the denominator is 0 multiplied by any of the three fractions here is just equal to 0. So what remains is dx over x plus dy over y minus dz over z is equal to 0. So this can be integrated, right? So integrating dx over x is just ln of x plus ln of y minus ln of z. And just like for the first example, let's say ln of c sub 2, because we are going to solve for the second solution. And therefore, this is just equal to ln of the combination of this x times y. And since naka-minus ln of z on, we are going to divide it by z. And this is equal to ln of c sub 2. So therefore, xy over z is equal to c sub 2. And this is our v of x, y, z. So this is our second solution. Okay, and we have our conclusion. So therefore, f of u v, which is equal to 0, is equal to f of x minus y over xy and xy over v. And this is equal to 0. And this is the general solution for the given partial differential equation in the Lagrange form. So example number 3, solve for pz minus qz is equal to x plus y quantity squared plus z squared. So our solution would be find p. We have ano yung naka-multiply sa small p? Z lamang. So we have q also negative p, because it should be plus capital Q times q. And our r is the whole right side. We have x plus y quantity squared plus z squared. Okay, now let's create our auxiliary equation. We have derivative of x over z equal to derivative of y over negative z is equal to derivative of z over x plus y quantity square plus z square. So from here, so we can easily use grouping method. From the first two fractions, we have derivative of x over z equal to negative derivative of y over z. And as you can see, we can just cross multiply them and we can cancel z. Okay, so let's just cancel them out. So we have dx equal to negative dy. And we can integrate this as easy as that. So we have integral of dx is just x. And this is equal to negative of y. And don't forget, we add c sub 1. So we have x plus y is equal to c sub 1. This is our first solution, u of x and y, because we don't have z. Okay, let's use this color. Yeah, so that's our first solution. So for our second solution, if you look at the third fraction, there is a x plus y, and x plus y is just equal to c sub 1. So we have, let's say, we equate the third fraction with the second fraction, that is dy over negative z is equal to dz over z squared plus yung x plus y, which is c sub 1, then quantity squared. So z squared. Okay? And as you can see, dz over z squared plus c sub 1 squared is can be integrable since ang variable natin dito ay z only. Okay, and by the looks of it, this can be du over u, but what are the things that we need? And if we integrate this, the derivative is 2z dz. And we need, kailangan natin ng z for z dz and a factor of 2. So that is by getting the z dun sa denominator. We have dy is equal to, let's say, negative z dz over z squared plus c sub 1 squared. And where do we get a factor of 2? Let's multiply both sides by 2. So we have 2 dy is equal to negative 2z dz over z squared plus c sub 1 squared. So as we can see, this is in a form of du over u. So we can easily integrate this. Okay. So integrating both sides, we have the constant 2, and integral of dy is just y. And this is equal to negative ln of the denominator z squared plus c sub 1 squared. And don't forget your addition of c sub 2. Okay. So let's transpose the ln. So we have, let's add this here, ln of z squared plus c sub 1 squared plus yung 2y is equal to your second arbitrary constant. And as you can see, this is not an expression or a function of xyz. Meron pa tayong c sub 1. And by the way, c sub 1 is just equal to x plus y. So we have ln of z squared plus x plus y quantity plus 2y is equal to your second arbitrary constant. And this is equal to v of x, y, z. And this is our second solution. Okay, so let's have our conclusion. So therefore, f of x plus y and ln of z squared plus x plus y quantity plus 2y, okay? Or rather, if we use brackets, okay, which is equal to 0, is the general solution the given partial differential equation in Lagrange form. Okay, so example number 4, let's solve for y squared z over x times partial derivative of z with respect to x plus xz times the partial derivative of z with respect to y is equal to y squared. And as you can see, this is just equal to y squared z over x p, dz over dx is just p, and plus xz q is equal to y squared. And we can also make it more simpler so that we don't have a term with 3 variables. Okay, so we can multiply both sides by x. So we have y squared z na lang times p plus x squared na z times q. Since we're multiplied by z, we have xy squared. So our p would be y squared z, or q would be x squared z, and yung r is equal to x y squared. Okay, the auxiliary equation is dx over, yung p natin is y squared z, dy is x squared dy over x squared z. This is equal to dz over xy squared. So even though we have 3 variables in each fraction, pairing two fractions, there can be cancelled variable in the denominator, by the way. So from the first two fractions, we have dx over, since parehas may z, and if we cross multiply, magka-cancel yan dalawa. So we have dx over y squared na lang is equal to dy over x squared. And as you can see, this could be cross multiplied also, so that we have our variables on one side. Okay, so we have x squared dx is equal to y squared dy. So let's integrate them. So integrating, we have integral of x squared dx is just x cubed over 3 is equal to y cubed over 3 plus say c sub 1 over 3 then. And multiplying both sides by 3, this is just equal to x cubed is equal to y cubed plus c sub 1. And transpose positive y, so we have x cubed minus y cubed equals c sub 1. And this is our u of xy. So wala tayong z. So the first solution. So for our second solution, compare the third, and let's say ano bang may ka-cancel ba tayo sa denominator? We only have x squared and x, and we have y squared. We have y squared from the first fraction. So let's pair first and last. So from the first and last fraction, we have dx over, so let's cancel y squared, so we have dx over z is equal to, for the last fraction, we have dz over x because we canceled y squared. And this could be cross multiplied, and we have x dx is equal to z dz. And by integrating this, we have x squared is equal to z squared plus c sub 2. Okay, so we disregard the denominator 2 already. So we have x squared minus z squared is equal to c sub 2, which can be our v of x and z. Okay, functions of z and x lang. So this is our second solution. So as a conclusion, so f of x cubed minus y cubed and x squared minus z squared, which is equal to 0, is the general solution of the given partial differential equation in the form of Lagrange form. So let's skip ahead and have our more complicated example. Okay, example number 5. So from the PDF or book na ginagamit natin, this is example number 6. Solve for y plus z times small p plus z plus q times small q, and this is equal to x plus y. So we are going to solve or look for p, that is just y plus z. Q is equal to z plus x. R is the whole right equation or right side, x plus y. So the auxiliary equation is dx over y plus z is equal to dy over z plus x is equal to dz over x plus y. If we try to use grouping method, we have the derivative of x and derivative of y in the denominator of x plus y and z plus x. So each fraction having 3 variables at a time. And we cannot cross multiply and separate all of them as easy as possible. We still have an expression or equality with 3 variables, and we cannot integrate it as simple as that. So we're going to use multiplier method, but can we easily find multipliers such that if we multiply it to the denominators and add them, we can cancel them all and equate to 0. So we have, if we make x plus y negative, so we can cancel x and y, but z would remain 2z. Multiply 1, let's say x only, xy plus z plus xz, so imbalance. Okay. Okay, so there's another technique is that uh, from the concept of, let's say, adding equivalent ratios, say 1/2 is just equal to 2/4, so 1/2 lang din siya. So, and also this is just equivalent to 3/6, still 1/2. And if we add the numerators, we have 1 plus 2 plus 3, and we add the denominators, we have 2 plus 4 plus 6. This is just equal to 6/12, and this is also an equivalent ratio of 1/2. Okay, so why not make another set of auxiliary equation that is just equivalent to their ratios. So we can just add the numerators. So we have dx plus dy plus dz. Over the addition of the denominator, we have y plus y is 2y, z plus z is 2z, x plus x is 2x. So we have a multiple of 2 of x plus y plus z. And also, we can equate this to another equivalent ratio by, so if we can add them, we can also subtract all of them. Right? Since 3 minus 2 is just equal to 1 and 6 minus 4 is equal to 2, so they are equivalent ratios still. So we can subtract pairs of ratios. So we have, let's say, dx minus dy over x plus z and minus the quantity of z plus x. So we have y plus z minus z is 0. So we have what remains is minus x. Same with a pair of the second and third, we have dy minus dz, and we can subtract the denominator also. So we have z minus z plus x minus x. So we have cancel the x, then minus y. And by the look of it, so this new uh, trio of ratios has also equivalent ratio with the auxiliary equation. So we can now use these things, okay, easily. And by the looks of it, as you can look at the last two fractions, this is just equal to, okay, a negative of derivative of x minus y over, we have the negative, so we change the signs in the denominators. We have x minus y. And we can easily see that this is just a negative of du over u. So we can integrate this. Also, same with the third fraction, meron tayong a negative of derivative of y minus z over, so we have z minus y, change this into y minus z because naglabas tayo ng negative. So we have du over u ren, so we can integrate this easily also. And if we took a look at the first fraction, we have the derivative of x plus y plus z over an x plus y plus z with multiple of 2. Then why not factor out that 1 over 2 there, so that we have x plus y plus z in the denominator. Okay? So, and siya. So we can now integrate all sides. Okay? And pair 2 of at a time. So from the first and the second, we have the integral of, we have 1/2 ln of x plus y plus z is equal to a negative of ln of the denominator is x plus minus y. Okay, and don't forget you add a constant, or let's say since there is a natural logarithm for both terms, we are going to take the natural logarithm of the arbitrary constant c sub 1 also. So now let's transpose, and to make it a natural logarithm lang, so we have ln of x plus y plus z raised to, let's say 1/2 can be put as a power. Let's say 1/2 is equal to, let's say we transpose negative ln of x minus y, we have plus ln of x minus y is equal to ln of c sub 1. So since we have addition of natural logarithm, this can be a natural logarithm of a product. So we have x plus y plus z quantity raised to 1/2 times x minus y is equal to ln of c sub 1. So therefore, x plus y plus z quantity raised to 1/2 times x minus y is just equal to our c sub 1. And this is our u of x, y, z. This is our first solution. Okay, and for combining, or let's say from the second and this is our third fraction, so we have pairing the second and third is just equal to, so the integral of dx, or the integral of negative dxy over x minus y is just a negative of ln of x minus y, and this is equal to the negative of ln of y minus z from the third fraction, so plus c sub 2, or ln of plus ln of c sub 2. So let's transpose. We have ln of y minus z minus ln of x minus y is equal to ln of c sub 2. So we have, this is minus, so we have to divide 1 minus and y minus z over x minus y, and this is ln of c sub 2. So therefore, y minus z over x minus y is just equal to c sub 2. So this can be our v of x, y, z, okay, as our second solution. Therefore, the conclusion is that f of uv is equal to 0 is just f of, the first solution is quantity x plus y plus z raised to 1/2 times x minus y, and y minus z over x minus y. Quantity equal to 0 is the general solution of the given partial differential equation in Lagrange form. So as you can see, we make another solution, or we make another auxiliary equation which has equivalent ratio from all of the fractions. Okay, so all of them are equivalent ratios. So rather than using the auxiliary equation where we cannot get easily an integrable part and cannot also equate the denominator to 0 easily, okay, we now use another set of auxiliary equations which are equivalent ratios of the auxiliary equations. Okay, So then now we can pair them easily as that. Okay. So another solution is that for multiplier method, you use multipliers, the conjugates of the denominator. Okay. So let's use y minus z minus x, and x minus y as multipliers. Okay. So if we use them, what would happen? Okay. So we are going to regroup, okay, things later. And this is actually slightly complicated because we are going to use our strength in algebra for regrouping and equating this to arrive on the our C sub 2 solution. Okay? Medyo madiwara yan. Madiwara. But we can use that and just show your strength in algebra. Okay? And technique is we must have some pair of the auxiliary equation or their equivalent ratio. And by the way, yung ating technique in multiplier method is equivalent ratio lang din siya because we operate with multipliers and we add their numerators and their denominators. Okay? So the goal is to make it simpler and we arrive with a denominator of 0. Okay? So that we can integrate them separately yung ating mga terms with one variable lang. Or if we make it by 2, diba? So just like here, we created another set of fractions that are equivalent dun sa ratio ng mga auxiliary equations. Okay? So yung addition of numerators and denominators would just be equal to their ratio then. Ganun din yung pagsubtract ng two fractions, both numerator and denominator. So ganun lang din. And they will have an equivalent ratio. Okay? Just like here, just like yung sa example ngayon, concept lang ng ratio and proportion. Okay? So you can also use multipliers, but this is more complicated than this one. Okay? The goal is we can find some integrable things. Okay? Dito, in natin so that we can have some du over u so that we can integrate it as easily as possible. So ganun din dito. Okay? And that's it for this lesson. And thanks.